All right, here are the notes. So you can copy them now, or like I said, I'm recording the video, so you can just watch for now, and then you can get it later. But it's going to be pretty easy. Okay, so today we're going to look at logarithmic. Still with logarithms, right? Logarithmic equations. Now, you've done some logarithmic equations in the past, but they're really easy ones. These are actually a little bit different, but they're just as easy, okay? So it's going to say solve each equation. Okay, and I'm going to just write a problem down and give you a shot at it and see if you know what to do, okay? Number 1, log base 8, parentheses 4x minus 8 is equal to, hey Anthony, good morning, log 820. All right, let me give you an opportunity to see if you can get that. Okay, so here it goes, because I don't want there to be a big pause on the video here. All right, so very simply enough, here we have a logarithm here on this side of the equation, and you have the same one over here on this side. You guys see it? That you've never seen that before. Yeah? So now, remember equal sign? That means equality. If this logarithm, what you're going to see, is the same as this one over here, these kind of just do what? Anybody have an idea what happens here? Yeah, pretty much you just be like, all right, if log of 8 is equal to log of 8, then we don't have to look at that. And you pretty much just put these, what? Equal to each other, yes? That'll be 4x minus 8 equals what? 20. That's an algebra 1 problem. And then you solve it and you get your value for x, right? That's going to be 4x equals what? Everybody got 4x equals 28? Yeah, because you move this over, it's going to be plus 8. Okay, you're going to get x equals 7. You see how easy that is? So easy. We're good? All right, let's do another quick one. We're going to go quick, right, because these are so easy. Number 2, the ones that are, there's some other type of problems that are not going to be this easy. We're going to get to those right now. How about that? What about that one? Is this logarithm in the base the same as this logarithm in the base? Then you kind of just drop, if those are equal, then you just set the expressions equal to each other. Yeah? So what's going to be the parts left over here? 5w plus 3 is equal to 13. Everybody get it? And then you're going to get what? 5w is equal to 10. I got w equals 2. Yeah? Okay. Again, going quick. If you didn't catch it, well, like I said, it'll be on the video, so you can go back. Log 6 of negative 2n plus 6 equals, well, it's going to be log 6. It'll be the same one, okay? So, again, it's just something that, like, if nobody ever tells you how to do this, and you'll be like, I don't know how to do that, but look at how easy this is, right? You look at it and it looks intimidating, right? Look at that problem, it looks intimidating. Yeah? But once you see that these and these match, right, then we can just drop that and we just put these parts equal to each other. Yeah. Everybody good? That's going to be negative 2n plus 6 equals 3n plus 10. Equals 3n plus 10. Okay, go ahead and solve that. Well, there's a couple of different ways to solve this and move things around, but I'm going to do it this way. I don't know if anybody's going to do it the way I am, but we'll get the same answer if we do the right moves. It's a good thing about math, right? It's absolute. Okay, so if you move this -2 in over here, which is what I'm going to do to make the ends positive on this side, and I'm going to move this +10 on that side, then I'm looking at this. I'm looking at 6, which was already there, and then -10 is equal to, and 3n that was already over there plus 2n. Okay, I'm going to get 5n equals -4. And you might have done it another way, but you get the right answer if you do the right steps. I got n is equal to, you guys got -4/5 no matter which way you worked it out? Yeah, you get this answer. So if you get a fraction, don't think it's wrong. I'm going to give you the answers to check anyways. Okay. Last one of these easy ones, number 4. Again, they look intimidating, but you could see that the math is pretty basic, right? All right, go ahead and try this oh, sorry. You see, the problems look like complicated and intimidating, but they're actually really easy if you know how to look at this and just solve it here. So, yeah, these the logarithms are the same. If that's equal, then you just kind of drop those, put this equal to itself. Anybody get an answer? Desiree? You got it? What'd you get? -3 is correct. Okay, so it's not a race, right? But I'm going to go ahead and got to move all the variables to one side, all the numbers to the opposite side. So I'm going to choose to do it this way. Again, there's not one correct way to do it here. There's several ways to do this. I'm going to move this over there, so all the variables will be on this side, which means the numbers will be on this side. And when I look at what I'm left with now, it's -4 minus 5 is equal to -2n plus 5n. Yeah, so I'm going to get 3n is equal to -9. Yeah, -3 is correct. Whichever way you solved it, if you do the right steps, you'll get the right answer. We're good? Yeah. Okay, done with the easy ones. These are the easy ones. Easy. Now, there's another type of problems that look like this. They're not going to be as easy. Here they go. Ready? Here they go. I'm going to see what you do with this. Ready? Check this out. Number 5. This is the second part. I mean, those are easy. Look at number 5 now. These are not going to be as easy. Look at this one. Log base 4 of 12x plus 3. I mean, they're going to look the same, but you're going to see it's not going to be the same. They're going to look the same. All right, you tell me what makes these different, and how do you know these are not going to be the easy ones? I mean, I still got this logarithm equal to this logarithm, right? Everybody agree? So we drop that. Everybody agree we're going to put 12x plus 3, whatever's here, this expression or number or whatever, equal to, then this one over here, the x squared plus 35. How do you know at this point that it's not like one of those easy ones? The squared. The squared. You know what something squared means? That means you're going to get a possible, how many? 2 possible answers, right? At most. This is quadratic. Remember they call it quadratic when it's yay, let's be happy when we see quadratics. Okay. All right, you got to be sharp. We did see quadratics and dealt with that last semester with in a different unit, right? Now we're looking at it again. So, hey. Anybody remember how to solve quadratic equations? How do we solve a quadratic equation? We're going to move everything to one side. You're going to move all this to one side. Everything. All the x's, all the numbers, everything to one side. But the x squared has to remain what? Positive, yes? The x squared has to... Do I want to move this x squared to this side? No, it'll make it negative. So if the x squared is positive here, guess what? I got to move what? The 12x and the plus 3. I got to move these that way. You guys agree? So this side will be 0. I got nothing left on this side. I moved everything out of this side. But now I'm left with what? I'm left with, well, I already had the x squared plus 35. That was already there. This 12x is going to become a what? A negative 12x, right, when you move it to the other side? And this positive 3 is going to be a, right, when you move something from one side to the other side of the equation, it changes sign? Yeah. And then kind of combining like terms and writing this and arranging this correctly. What's left? This. 0 is equal to what? X squared minus 12x, right? That's the only, right? Put it in the correct order. X squared minus 12x plus 32. Is everybody good? All right. And then guess what you have to do with this? We have to factor it out. You guys remember that? How to factor quadratics to be able to find the solutions. They are going to be factorable. That's the good news. They will be factorable. And anybody remember how to find the right combination of numbers that go in these parentheses? Remember, they have to be 2 parentheses like this. Oh, I know it's going to be x and x. Anybody know how to do this? Because some of you, you know, when you were learning this, it was sharp in your head, but now you forgot. I'm sorry? Okay, I know you're getting me the numbers at work, but I'm trying to ask you, how do you know the numbers have to multiply to 32, yes? So if I were you, I know some of you are sharp, you can do it in your head, but if I were you, you write all the multiples of 32. What possible combinations of numbers can multiply to 32? 1 times 32, 2 times 16, 3? No, not 3. 4? Oh yeah, 4 times 8, 5, no. 6, no. 7, no. And then 8 is this one because it's 4 times 8, 8 times 4. Everybody agree these are the set of integers that will multiply to a 32? Yeah. And then which one can give me a 12? Well, 4 and 8, right? That's how. So it's going to be a 4 and an 8, yeah? And then you got to watch the signs. What's it going to be for the signs? They're both negative. This should not be the first time you're factoring. You guys should remember this. And it looks like most of you do. Okay, that's the way it factors. So that means the answers are negative 4 and negative 8? No. You guys remember how this works? You're supposed to do what? You're supposed to put this parentheses, x minus 4 equal to 0. And you're also supposed to put x minus 8 also equal to 0. Oh, that's not a 0. 0. So what's going to actually be the solution for x here and the solution for x here? Remember, it's the opposite? Yeah? But that's the reason why. So what are the 2 possible solutions that are going to happen here? X equals what? Positive 4? Because you move the negative 4 to that side. And this one's going to be x is equal to what? Positive 8? Yeah? Well, yeah. Now you're actually, listen to this. Actually, you're not really done with this problem. You're supposed to get these and substitute them back in here and see and verify that they both work, because there are some problems where only like one of these works, or sometimes both of them don't work. But I'm going to choose the ones that both of them work, okay? I'm going to choose the problems where both of them work, so you just bring it and stop right there. Okay, one more just like this one, just to just to see if we're good, okay? Questions on this one? No, we've seen this kind of math. Last one, 6. Let's go to the last one, 6. So log 3, 4k squared minus 16k, what? Is equal to log 3. I'm telling you, they look intimidating, but they're not that bad. Okay. What the heck is this? Well, when you have this same logarithm equal to the same logarithm over there, we can just drop that, right? These will be the same, so make sure that's true, which will be true. So we're just going to put these expressions equal to themselves, yeah. That'll be 4k squared minus 16k equal to this, negative 60 plus 3k squared. Oh, yeah. All right, talk to me. Which way do we want to move? Sometimes we move everything to the left. Sometimes we move everything to the right. What determines that? Just how you feel that day? No. Yes, where you got to look at the squared part, right? You got to look at the squares and see. You got to move it so that when they come together, it leaves it a positive k squared, right? Or x squared or whatever. So you tell me which way we got to move. Which way do I have to move? Which ones got to move? This stays or this moves? This moves to that side? Correct. Look at the squares. What happens if I move this 4k that way? You guys see when you add it, you'll have a negative k. We don't want the square to be negative. So correct. We're going to move these two to that side. So it'll be 4k squared minus 16k. And now it's going to be minus 3k squared, or if you want to write it under here, yeah, let's write it under here. Minus 3k squared minus 60 equals 0. Okay. Well, however you did it. What's left over? What's left over? I got positive k squared or x squared, whatever, minus 16k minus 60 equals 0. Is that good? Is that what you guys got? Cecilia, did I mess up? What the? Anybody? I did that on purpose and she's the only one paying attention. She's right. You see? Pay attention. Don't trust nobody, not even me. Yeah, this positive 3k squared, when I moved it over here, yeah, it became negative. And what happened with this negative when I moved it to that side? Does it stay negative? No, it should be what? Hello, good morning, wake up. Yeah, watch out. One little move like that will mess you up, right? Okay. All right. Thank you, Cecilia. All right. And what? And this will be factorable. 60 actually has, this 60 has a lot of numbers, a lot of pairs of numbers that multiply to 60. All right, here we go. Starting with 1. 1 times 60. Yeah. 2 times something. Yeah. 2 times 30. Yeah. 3. Yep. 3 times 20. 3 $20 bills is $60, right? 3 times 20. 4. Yep. 4 times 15. Anybody know your 15 times tables? Yeah. 5. Well, yeah. 5 times 12. 6. Ooh, all of them. Damn, what the? You see? There's no way you can see all this in your head and then see which ones add or subtract to 16. That's what I'm telling you. Populate a list of all the factors, all the multiples of sets of numbers that give you a 60. And then you can see which ones add. Sometimes they have to add to the middle number. Sometimes they have to subtract. 8, no. 9, no. 10. Once we get to 10, we're back here. See, there's, Okay, so which one is it? The 6 and the 10, see? Okay, 6 and 10, I agree. 6 and 10. And it just so happens that both of these are going to be negative again, but that's not always going to be true, right? Sometimes one will be plus, sometimes one will be minus, sometimes they'll both be plus, they'll both be plus. Okay, long story short, what's the answer for this one? Or what's the one possible solution for this one? Positive, right? Yeah. I'm telling you, this is not new. And this one is what? Yeah, see? This is all algebra 2. That's why you had to learn all this and learn it well for algebra 2, because see, you're applying it here for pre-calc material. Okay, let me stop this recording.